So starting off, we got postulate 16, corresponding angles converse. On all of these things that we're doing today are converses, which means they're taking the original term we learned, and remember converse switches the order, right? Just like we learned conditional, converse, inverse, contrapositive. So these are converses, so they're taking postulates and theorems we already learned, and they're flipping them around. So we got corresponding angles converse. If two lines are cut by a transversal so that the corresponding angles are congruent, then the lines are parallel. If you remember, the original corresponding angles postulate said that if the two lines are parallel, then the corresponding angles are congruent. So now we're saying if the angles are congruent, the lines are parallel. And theorem 3.8, the alternate interior angles converse. Two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. All right, so if the corresponding angles are congruent, then we know the two lines are parallel. If the alternate interior angles are congruent, then we know the lines are parallel. And then I'm just going to kind of shorten these up. The consecutive interior angles converse. If the two consecutive interior angles are supplementary, then the two lines are going to be parallel. And if the alternate exterior angles are congruent, then the means the lines are going to be parallel. All right, so just converses of stuff that we already covered. So just looking at those in reverse. In other words, we use these to prove that two lines are parallel, whereas we used parallel lines before to prove that the angles would be congruent to each other or supplementary. All right, so a little proof here. Given that the measure or that M is perpendicular to P and M is perpendicular to Q, we want to prove that P and Q are parallel. So just like always, we're going to start with the given. Which is going to say that there we go. M is perpendicular to P and M is perpendicular to Q. And because M is perpendicular to these two lines, what do we know about angle 1 and angle 2? They are congruent, but we got to say something else before we can say they're congruent. No, not quite. They are corresponding angles. But what do we know about these angles? If they're perpendicular, perpendicular means that two lines intersect to form what? Two lines intersect to form a right angle, right? So if they're perpendicular, then that means angle 1 is a right angle and angle 2 is a right angle, right? Which comes from the definition of perpendicular lines. They're going to intersect to form right angles. So I can say angle 1 is a right angle and angle 2 is a right angle. Another one you could have used, another reason we could have used instead of definition of perpendicular lines is there was a postulate that we learned last week that said if two lines are perpendicular, then they form four right angles. So we could have used that postulate as well, but definition of perpendicular lines works fine here. And then if those two angles are right angles, since they're both right angles, what's that tell us about the two angles? Jorge, you want to say that earlier? The two angles are going to be congruent. So angle 1 is congruent to angle 2. And that's based on the fact that all right angles are congruent, which is a postulate we learned last week as well. And so if these two angles are congruent, since based on their placement, we know that these two angles are corresponding angles. And we've got two corresponding angles that are congruent. Then we can go back to this postulate right here, postulate 16. It says if two lines are cut by transversals so that the corresponding angles are congruent, then the lines are parallel. So since 1 and 2 are congruent corresponding angles, then we can say that line P is parallel to line Q, and that is the alternate I'm just writing that wrong. This is the corresponding angles. Converse postulate. All right. So P and Q are parallel because we got to the point where we could prove that the corresponding angles were congruent. All right. So next up, another little proof. This one's actually easier than the last one. So we're given the angle 5 is congruent to angle 6 is congruent to angle 4. Ultimate goal to prove that this line AD is parallel to BC here. And so starting off with given, angle 5 is congruent to angle 6. Angle 6 is congruent to angle 4, which is given. And then when we look at this given information, we got 5 congruent to 6, 6 congruent to 4, or in other words, 5 and 4 are both congruent to 6. So since they're both congruent to the same thing, then 5 and 4 should be congruent to each other. By what rule or property, anybody? Two things congruent to the same thing, so they're congruent to each other. Use it all the time. It is the transitive property. And we're going to say of congruence, because we're talking about things that are congruent to each other. And so if we look at 5 and 4, 5's here, 4's here, which if we're looking at line AD and BC, sometimes it's hard to kind of see it when it's just a segment, so it stops. But 4 and 5 are on different sides of this line AB, which if you draw it all out, it looks a little more like a transversal and two lines that it's intersecting. And 4 and 5 are on different sides of that transversal, and they're in between the two lines, so they're alternate interior angles that are congruent. And if the alternate interior angles are congruent, then we learned on the first page today, alternate interior angles converse, if two lines are cut by transversal so that alternate interior angles are congruent, then the lines are parallel. So Once we've got 5 and 4 congruent, we can jump to that AD is parallel to BC. By the alternate interior angles converse. All right. Questions on that one? Math stuff. Find the value of x that makes m parallel to n. All right, so m and n, in order for those to be parallel, then these two angles, which are in the placement of alternate interior angles, the alternate interior angles would have to be congruent for the lines to be parallel by the alternate interior angles converse. Right? It says that if alternate interior angles are congruent, then the lines are parallel. So, to find the value of x that's going to make these parallel, we've got to find the value of x that makes these two congruent to each other, or these two values equal to each other. So, set it up. 2x plus 1 equals 3x minus 5. Subtract the 3x over. So negative x plus 1 equals negative 5. And subtract 1 from both sides. So we negative x equals negative 6. And then divide by the negative 1 to get a positive x. And 6 is going to be the value that would make those two lines parallel. All right, so then the next ones, we got 2x plus 8, 4x minus 4. The location of these two angles, they're between the two lines on the same side of the transversal, making them consecutive interior angles. And in order for two lines to be parallel, the consecutive interior angles have to be supplementary. So those two together have to add up to equal 180. So 2x plus 8 plus 4x minus 4 is going to have to add up to 180 to make them supplementary. So 2x plus 4x, 6x, 8 minus 4, 4, 180. Subtract 4 from both sides. 6x equals 176. Lastly, divide by 6 on both sides. And 176 divided by 6. X going to be actually 29.33 repeating, or 29 1/3 if you want to put it that way. All right, questions on those? Basically, what you got to recognize is alternate interior angles have to be congruent for the lines to be parallel. Alternate exterior angles have to be congruent for the lines to be parallel. Of corresponding angles have to be congruent for the lines to be parallel, and consecutive interior angles have to be supplementary. So they're the one, that's the one oddball, is if they're on the same side in between the two lines, they have to add up to 180. Everything else you would set equal. Alright, so next one, you notice that when your windshield wipers on your car are stopped, they each made a 30-degree angle with the bottom of the windshield. If the wipers were long enough, would they ever cross each other? Explain. So, get a set of windshield wipers, and when they stop, you see that both angles are 30-degree angles, and it wants to know if we extended those out far enough. We just kept going in both directions. Would they ever cross each other? Would they intersect? Why not? Because the fact that these two angles are congruent makes those two parallel. Because these two angles would be what kind of angles if these are two lines and a transversal? They're both in the same location, right? They're at the top right of the intersection, making them corresponding. And so if the corresponding angles are congruent, then the lines are parallel. So the no part is easy. The explain part takes just a little bit. So I'm going to say because the 30-degree angles are corresponding angles. So by the corresponding angles converse, by the corresponding angles converse postulate, the wipers are parallel. So basically, since the corresponding angles are congruent, the lines, being the wipers, have to be parallel to each other. All right, so lastly, we got this picture here. What to determine is line AB parallel to line DC. So AB and DC, talking about the bottom line and the, oh, that's not very straight. Let's try that again. Top line. So trying to figure out if those two would be parallel. And so when we look at those two, line AD and line BC, those would be representative of transversals, and so would DB and AC. Those, so we got 4 possible transversals we could look at connecting these two lines. And so what we want to look for is a set of transversal that has 2 angles that we know the measure of, which between these two, DC and AB, the only one of these transversals that has an angle at both sides is DB. And for DB, we've got an angle there and an angle there, which those would be what kind of angles, what group of angles, since they'd be on different sides of the transversal in between the two lines. Makes them alternate interior angles. And if the alternate interior angles are congruent, which they are, both 65, then the lines have to be parallel by the alternate interior angles converse theorem. So AB parallel to DC, that's a yes. because the alternate interior angles were congruent, those 65-degree angles. And then next up, it wants to try to determine whether ray BC and ray AD would be parallel. And so we look for one of the transversals, which there's 1, 2, 3, 4 possible transversals again. Looking for ones that have angles that are attached to these two lines, which the only one that has angles attached to both lines is the 115 and 155 here from line DC. So when we look at these two angles, they've got a pair relationship that they are the corresponding angles, right? Same location in reference to the intersection. But when we look at the corresponding angles, 155, 115, not the same. And in order for the lines to be parallel, the corresponding angles have to be congruent. So our answer is going to be no, those are not going to be parallel because the corresponding angles are not congruent. All right, questions there, anybody?